Hi, thank you for joining. I think we're going to wait just a minute for other people to get online, and then we'll begin. Okay, well, I'll kick it off. Good afternoon, everyone. My name is Patricia Jordan. I'm a regional marketing manager at Interface Engineering. Thank you for logging in today. Welcome to our second installment of our 2026 High Performance Buildings Educational Series, Smart Infrastructure, Connecting Lighting, Power, and HVAC through IoT, the Internet of Things. Presented by Associate Principal and Senior Lighting Designer, Kristina Santi, and Principal Michael Flemming. Before we get started, we have a couple housekeeping notes. We're using a GoToWebinar meeting platform. All audience microphones will be muted during the presentation. However, please feel free to enter your questions into the questions field. There are two different versions of the GoToWebinar, so depending on the version you selected, the question field is either on the top bar with a chat box and a question mark, or it needs to be popped out of the control panel as it looks on the right of the diagram or of the slide. We'll leave about 10 or 15 minutes at the end of the presentation to answer questions. If we do not get to some of the questions posted, we'll distribute a Q&A summary to everyone. Today's presentation will be recorded and made available through our website and YouTube channel. Interface Engineering is an approved AIA CES provider, and for today's participation, you'll earn 1 LU HSW. All attendees will either receive a course completion certificate, or if we have your AIA number, attendance will be reported to AIA for you within the next 2 weeks. A little bit about us. Interface Engineering is a 100% employee-owned mechanical and electrical engineering firm specializing in high-performance building systems. Our services include mechanical, electrical, plumbing engineering, fire life safety engineering, lighting and daylighting, energy consulting, building technologies, and commissioning. We focus on sustainable design and occupant well-being, partnering with clients to deliver practical, innovative solutions that create optimal environments for life. We have 12 offices nationwide and a team of over 200, and we're continuing to grow. The presentation today will be led by Associate Principal Senior Lighting Designer Kristina Santi and Principal Michael Flemming. Kristina brings 15 plus years of experience in lighting and electrical engineering, is known for delivering design-driven, energy-efficient solutions and leading teams across a wide range of projects. Michael brings strong expertise in commissioning and high-performance building systems, known for his practical, collaborative approach and focus on efficient, reliable outcomes. Today, we're looking at how IoT is reshaping building systems, bringing lighting, electrical, and HVAC together into smarter, more responsive environments. And with that, I'll turn it over to Kristina and Michael.
Thanks, Patricia.
Thanks, Patricia. So I'll get us started today. We'll briefly bring up our agenda for today. So we're going to start by just going over the course description and then jumping right into what is the Internet of Things, sort of giving you a little bit of background information to get up to speed. And then where we go from there is talk about specific applications of the Internet of Things depending on different building types that we will encounter. And then finally, we finish up with what are the steps? How do we then implement the Internet of Things for being able to connect sensors, systems all together for a smarter, well-connected building? So our course description for today, I'm not going to go into the full detail of what is in the AIA description, but ultimately today here we're going to talk about how we can utilize the connection of all of these different systems in a modern building, whether they be lighting controls, electrical distribution, mechanical systems, and a whole bunch of other ones into a full, complete smart building. We're going to talk about how different sensors and devices can be used to interconnect all of these different systems, what the important items are when it comes to cybersecurity and implementation strategies, and then finally, really what architects, design professionals need to know about how being able to use data analytics for improving building performance and overall energy efficiency gains. So our learning objectives for today are going to be focused on defining what some of those core concepts of IoT are and how they adapt and apply to modern building systems. We're going to describe lighting and lighting control systems, including the parts and smarts that go into it and how those work together for a centralized managed platform. Then we're going to explain how all of these different systems, whether they be electrical, smart metering, lighting controls, HVAC, all tie in together and how we can analyze that data to help make a well-performing building. So on that note, I'm going to hand it over to, I always forget our quick poll. So want to get everyone jumped into this if we can from the beginning. So if you are on your phone, if you can scan the QR code on the screen, or if we go to the next slide here, there's a link that you can click on, just sort of looking to see what field do you work in, who do we have on the line today, and who's involved in this webinar today. So we'll give everyone a minute just to fill it out and identify who we got on the line today.
You missed the scan on the first screen, you can use the scan on QR code on the screen as well.
All right, well, it looks like we got a good mix of engineer and architects. We did this earlier this morning and we ended up with a whole bunch of others. So not sure what those were, but happy to have a good design group here with engineers and architects out today. So yeah, on that note, we'll hand it off to Kristina to get us started.
Hi, everybody. So we're going to talk about what is the Internet of Things. The Internet of Things refers to devices, objects that are embedded with sensors and software and certain technologies that enable them to connect and network, collect data, and exchange information with other devices. And then those systems can be used to improve the system without human intervention. I'm going to kind of go through a little bit on this wheel chart here. So first we connect our devices up to the system. Those sensors collect data and they transport and access that data, whether that be uploading to the cloud or onto a local network. Then the data gets analyzed. It then gets processed into what actions do we need to take with this data, how we can improve the system that we have for the Internet of Things. And then that in turn increases the human value and the experiences of users and also owners of buildings. Some examples of Internet of Things use, smart home appliances. So you may see at home you have your Alexa system or other smart home connected devices. A lot of the times you're using the Internet of Things and you don't even know in your day-to-day life. Wearable health trackers such as Fitbit and Apple iWatch, connected digital controls in commercial buildings. So we have a lot of our lighting control systems, our HVAC controls as well. They're networked these days in digital systems, so they have a lot of connectivity. We'll go through that a little bit more detail later on. Equipment monitoring, so checking the status of equipment and machines to make sure they're running smoothly and there's no issues. Environmental monitoring, so you can track data such as temperature and humidity for environmental purposes. Asset tracking, so we'll get into a little bit more about what that entails in the presentation. Retail tracking for inventory and shipments. So we'll go into that a little bit more, but just tracking where all your stock and your inventory are in specific buildings. and many, many more. There's a lot of applications that we haven't even realized yet, that having this backbone and this IoT system, you can really build on it in the future. So many more applications to come. What does the Internet of Things do? So the Internet of Things uses devices and they connect in certain protocols. Those can be Wi-Fi, Bluetooth, cellular networks, also Wi-Fi is one as well that's being used at the moment. They all connect and network to transmit data to a cloud or a local network where the information is then processed and analyzed. The Internet of Things enables everyday objects to become intelligent and interactive, and that in turn optimizes energy uses and it enhances convenience. The Internet of Things allows systems to make decisions and trigger actions automatically. So, such as you can adjust your temperature via thermostat, or it can alert maintenance for a machine before it breaks. Internet of Things devices are used to monitor a wide range of parameters, such as temperature, humidity, air quality, energy consumption, and machine performance. So this data is analyzed in real time to kind of identify trends and anomalies that can help businesses optimize their operations and also improve their bottom line. What is the value added? So I know a lot of you probably heard of the 3-30-300 rule, and that's referring to the cost that a building owner has to put in to a building, and it's separated in those three categories. So the 3 is the energy cost, the 30 is the cost of the building, and the 300 is the cost of the people within the building. But Jones Lang LaSalle did a further study that also included a security aspect to that. And that was where the 3000 comes into. And that's really relating to cyber attacks and cybersecurity and risk avoidance for legal fees, ransomware, and certain procedures. So with an Internet of Things and a connected network does come some risks for cybersecurity issues. And we'll talk a little bit about that. Those risks can be mitigated, they can be reduced, but there is always a little risk when you come with a connected system such as IoT. So we really have to look at, will this cost of this IoT system offset these potential risks? And so firstly, we have to look at what opportunities do we have in our building, whether it be a new building or existing building. What problem will this solve if we implement this Internet of Things system? And what existing systems and infrastructure do we have in our building, and how will that be impacted? Maybe you have an older building with older systems, and therefore in order to implement an IoT system, you need to upgrade maybe a lighting control system or a HVAC system. But if you're going to do that anyway, then maybe implementing some IoT into that, in considerations into that while you're already putting forward that cost is a smart way to move forward. Secondly, setting up these IoT systems can future-proof your buildings for new applications that are not even realized yet. So setting this up now, you may be able to implement a lot more systems down the line. And as a designer, we have to think about, what building are we working with? Are we working with an existing building? What limitations does that have? How are we going to integrate any IoT systems into the design? And then looking at a new construction. This is probably a lot easier, but we have to really design this at the beginning of a project. Thinking about the IoT solutions, also thinking about the networking. How is the lighting system going to talk to the HVAC system, the security system? So thinking about that at the beginning is really important. And now we're going to go into lighting and lighting controls and how that ties into the Internet of Things and the applications. I'm going to start a little bit on the history of lighting and the LED chip. LEDs came into the world about 25 years ago now, and when they started, they weren't very efficient and their quality wasn't great. But over those years, we've really improved with the quality and the efficiency of the LED, such that it came to a point where there wasn't really much in technology-wise for LEDs to improve on. So the next step has been within the last 5 or so years is really embedding this technology into the lighting fixtures themselves. So you will see a lot of embedded sensors now in lighting fixtures. And so, you really need to think about how these can work together. And then there's some limitations on the embedded sensors as well. But definitely a lot more technology is available in luminaires these days. We're going to look a little bit at heat mapping and how that applies to lighting fixtures, indoor positioning, personal environmental control, and building energy optimization. So why lighting? Why do we use lighting to implement the Internet of Things, and what makes it such a good place to start? Lighting is distributed. You can find lighting within the whole interior of a building, also within the exterior spaces of a building as well. It's just distributed throughout, so it really makes it a great device to use in order to implement Internet of Things. It's electrified. It has power, but these days it also has data cabling as well through the control system. So through a digital lighting control system, all of your luminaires are connected via Cat5 cabling. Also, if you have PoE connected lighting, it also has that data network and the data connection already built into the lighting system. Lighting is elevated, so it makes it a great place to look down and see and collect data, being located up into the ceiling. So it makes it a really great spot for it to be able to collect data. Lighting is discrete. You don't have to add any other devices on ceilings, on walls. It's integrated quite nicely in a lot of the fixtures where you can't see a lot of the sensors. You already need the lighting, so you don't really have to add any more bulky devices within the spaces themselves. And so one of the biggest ways that Internet of Things collects data within the building and MEP lighting world is sensors. And sensors can be used to log more than just occupancy. They can be used for non-lighting applications as well. So you can see in the little chart here, there's many different applications. They can be used to sensor temperature, humidity and moisture, acoustic and sound vibration issues, chemical and gas can be detected, flow rates of water for plumbing and for fire systems, torque and force and load pressure, leaks and leak detection in buildings, electric and magnetic forces, acceleration and tilt, machine vision, and position, presence, and proximity. So they can log lots of different data. You can have embedded sensors in other devices such as lighting, or they can be separate devices as well, as long as they're networked into the system. And so within our smart building solutions, there are many different aspects that can be connected through the Internet of Things. This can be access control through security systems, digital signage to change signage displays, shade control. A lot of our shades can be integrated into our lighting control system, or some can be integrated separately. Renewable energy and logging the amount of energy you're using. Environmental monitoring, air and temperature, humidity. Life safety systems can be monitored to make sure that they're online and working. Data dashboards can be displayed with the data. Energy reporting reports can be made. Workflow optimization between staff. Critical power systems to make sure they're online and their status. HVAC systems and their controls. Lighting controls. And energy metering. So there's loggers meters that are on the different panels, and they can show trends of data. So a lot of these can be connected. Some are easier to connect to others, such as the HVAC system and lighting control system. We see them connected quite regularly through BACnet, but many other ways. Some can be standalone and some can be connected together. It helps if it's a digital system rather than analog, but analog devices can be added to a digital system with a relay. And one of the biggest lighting-based IoT applications is heat mapping, which determines the utilization of a space. So basically, it uses sensors. They can be embedded in the lighting fixture or they can be standalone. And it detects when a person or people are using a space over a function of time. It is then overlaid onto a floor plan, like you see in the diagram here. So this helps a building owner or someone that's a tenant see how their space is being utilized. So you can see areas that are not being used and areas that maybe are being overutilized, and ways that you can plan out your space better, or you can shut off certain lighting or HVAC systems in areas that are not being used. So sometimes this is a good first step just to see how your space is being used. These sensors can then log this data and be able to provide data back to the user. It uses passive infrared sensors to detect. Another system that uses the luminaires are indoor positioning system, which is also called IPS, or real-time location services, which is RLTS. It's a system designed to provide occupants with instantaneous awareness of their location. So there's two ways that we can do this. It's through a Bluetooth radio transmission from the luminaire, and that is picked up by a Bluetooth in your phone, and it tells the user where they are in the space. So if you're shopping and you're trying to find something, you can use this system to be able to locate yourself and then where you need to go. It also uses encoded light. So there's a unique fixture ID that's encoded into the light fixture. It's emitted by the luminaire, and the camera in your phone picks up that signal and can locate you on the plan. So these occupants will access the data via an app, and that will use GPS or Wi-Fi systems to send that data back and forth. Building owners can use this data to interact with their occupants, and they can use the data for marketing and operational strategies. And so IPS will send this data, and then it will upload it to the cloud to update the map with the positioning data. Next, we have personal environmental controls. So this allows individuals to control their own space, but it also results in some energy savings as well as higher occupant satisfaction. So a lot of these occupant preferences can be saved and used to provide preferred settings. So a few examples of these is your parking wayfinders, or knowing where there's spaces available to parking. That's an Internet of Things system as well. Colleague and wayfinding, so finding where your colleague is within an office building. Space booking and collaboration, so booking conference rooms and spaces, and flex desks, flexible workspaces as well. Personalized comfort, so there may be some areas that have a higher heat load, and so they need more cooling than others, so they can be optimized. Optimal performance, so it can really see where there's people located in the building, and it can adjust HVAC or lighting systems accordingly. And then security systems, it knows where people are within the building, so that really helps with where people are for security reasons as well. Asset tracking. So asset tracking refers to the location of equipment of a physical object, such as equipment or an occupant within a space. Asset tracking uses RFID or Bluetooth which is emitted from a tag that is placed on an object or an occupant, so you can see where they are in the space. And you can see on the right, there's a little map showing different codes for people and objects on a floor plan. Lighting equipment that has this type of technology can sense the transmission of the tags within the space. The acceleration, location, and the temperature of the objects can be received. And so this application has many uses in warehouses where they can track packages or stock, or in hospitals where they can track medical equipment.
So at its most basic level, lighting controls occupancy sensors were used for energy optimization. The idea was to utilize occupancy sensors, daylight sensors, other things like that in order to help reduce the energy usage of lights when there was no one in the spaces or when there was enough natural light. But now as LEDs are more used and as occupancy sensors are more prevalent throughout the building, the use of these sensors are adding more and more to buildings as they go along. So now one of the most basic levels we're seeing, and one of the items that are day-to-day in code now, is utilizing occupancy sensors as part of setback temperatures in order to help reduce the heating and cooling of an empty space, in order to help reducing the ventilation required in spaces when there's no one in them. So that's sort of been stage 2 now of what we're seeing for energy optimization coming out of occupancy sensors. But as the technology grows and as they become, as Kristina mentioned, more and more prevalent throughout the building, we're starting to see additional options for energy optimization to help improve and reduce the energy usage of buildings overall. Another application that we're seeing on the next slide here is we're also starting to see it utilized as part of security as well. So as our systems are growing more and more connected, and as the Internet of Things is allowing us to take sensors from one system, such as our lighting control, and apply it to other systems and integrate with systems such as our access control or our security systems, we're able to utilize this information more and able to create alerts or alarms when occupancy is detected in an area where maybe there's been no card scan to get in. So by utilizing these sensors that are already existing as part of a lighting system, we're able to improve and reinforce the safety of the space through our security system. As well, on the opposite side of the energy saving side, where we talked about reducing ventilation or reducing the heating and cooling load of spaces when they're empty, we're also able to utilize occupancy sensors to sense when a space is heavily occupied, and using that as a proxy for increasing ventilation to ensure for healthier environments when the spaces are more or occupied at a higher level than maybe was assumed in the design. And then finally, by integrating our egress lighting into our security system and allowing these two systems to talk, we're able to improve our egress path and our lighting, showing people the way out of buildings in case of emergency. By communicating with the fire alarm system, we're able to direct people away from hazards, so that if there is a fire on the path of egress, people and occupants in the building know not to go in a certain direction and not to run towards where there might be a hazard. So by integrating all of these systems together, by utilizing sensors on different systems, we're able to make our buildings safer and smarter overall, and hand in hand with that, also more energy efficient. I'll hand it over to Kristina to sort of talk about additional different building types and usages that we see for the Internet of Things.
Thanks, Mike. Yeah, so now we're going to look at how Internet of Things is used in different building types and settings. In retail, so heat mapping can be used in retail applications. You can see the diagram on the right-hand side here. It can track the path of the customer within the shopping center, but within the individual store itself as well. It provides benefits both to the owner and to the customer. It can track customer purchases and recommend products. It can use this traffic data to adjust staffing. So if you're not having many people enter your store at certain times, you can adjust your staffing to accommodate for that. It monitors trends, so you can see where people are walking into the store, the paths they take, where they kind of take, they go first, and so it can they can rearrange the store in order to have specific products that they want to sell and move them into those high traffic areas. It can prioritize displays by adjusting the amount of light delivered to target areas and merchandise that they want to sell. Customers can use these devices to quickly find their product, so they can use the data to help them find certain spaces within the stores. And it can also track merchandise. So you see the warehouse diagram on the bottom here. It can track how much inventory a warehouse has. So the darker colors can mean you have full inventory, and the lighter colors is, you're starting to get low. You may need to restock certain items. So that can really help efficiency in these type of applications. Now we're going to look at healthcare and medical devices. So asset tracking is used in healthcare to help monitor where the location of equipment is, such as wheelchairs, gurneys, and portable medical equipment. It helps locate that equipment quickly so that patients can be seen to sooner. Beds and rooms also then become available sooner. That helps not only the patient turnover, but the amount of time that a patient is seen. Indoor positioning can be used to monitor the location of patients. If they're moving from surgery to recovery, it can make sure that staff know where to go so that there's someone there when they reach recovery. There's a lot of networked wearable devices that can provide multiple types of data to monitor a patient's health. So you have a wide range of these medical devices that connect via Bluetooth or Wi-Fi. You have the standard consumer products such as Apple Watches and Fitbits that track your heart rate. You have a lot of wearable external medical devices, such portable insulin pumps or medical dispensing devices. Internally embedded medical devices, so pacemakers and other devices implanted in the patient. They communicate wirelessly, and they can connect and upload data to your doctor, to the internet. Stationary medical devices, so a lot of hospital-based medical dispensing or home care cardio monitoring for a lot of patients that are bedridden. They can be used to send their health status via the network for hospitals or homes. Transportation applications. They also use asset tracking to monitor the locations of equipment, luggage carts, wheelchairs. This helps increase the efficiency for travelers to find what they need and get going quickly. Indoor positioning also helps to provide travelers the next path on their step. Provides timing to help travelers plan out where they need to be to make sure there's no delays, not only for them, but for everybody else on their flights too. So you can see a little bit of the passenger experience and how that relates to if you catch a flight, for example, you check in at home, so it knows that you're on your way. It might tell you where your check-in counter is, which check-in, how long the check-in line is, any promotional materials. There's also little tags that they put on your bags these days that will track your luggage. So it'll tell you where your luggage is on which carousel, and it'll tell you how long that it's going to get there. And it just really gets you on your way and quicker to get out of the airport. So all these can be used in transportation applications. Hospitality, again, there's benefits for both the owner and the guest. The owner can help coordinate housekeeping staff by knowing when people are in or out of the building. They can also save energy on lighting and HVAC loads. So when there's no one in the space, it's not occupied, they can turn off lighting, they can turn off HVAC to save energy. And analyze guest habits, booking trends, and rates. It helps track maintenance needs more effectively, so you can log which room needs maintenance, and that causes a lot less room downtime by organizing your maintenance staff, so therefore you have higher profits. Guests can access their room with their phone and set lighting, AC, television via their phone, and it also remembers these profiles, so you can access these settings next time for your next stay.
One space type that we're seeing a lot of applications for energy reduction and for load setbacks is definitely on the lab and life science side of things. Lab spaces, especially things like fume hoods, exhaust systems, HVAC overall, are a large energy hog on life science systems because of the need for environment, health, and safety in these spaces when dealing with different types of chemicals and different types of uses within the lab. So one of the big applications that we're seeing is utilizing occupancy sensors, utilizing asset tracking, utilizing heat mapping to be able to identify the uses of space and be able to back off equipment when necessary. So one of the easiest applications is being able to utilize uh, occupancy sensors, detectors in front of fume hoods to be able to back off on the exhaust air if there is no one directly in front of the hoods or if no one happens to be using it. Additionally, we're able to track what's in the actual airflow and identify if there are contaminants in there or if there isn't. And that also allows for energy savings by backing off on the exhaust air. But additionally, at a higher level, by tracking the uses of the hoods themselves, of the equipment within the lab, we're also able to ensure that the labs themselves are right-sized for the applications and right-sized for the uses that are happening with that specific owner. If they track the lab usage and identify that only a handful of the hoods are being used within a specific lab, or that it's not being maximized, then in some cases they're able to right size their equipment and right size their labs and ensure that we're not using high energy usages when the spaces aren't even actually being used. So moving forward, let's jump into another one of our quiz or our poll questions here. And now that we've sort of talked through all these different applications, different market sectors, and how in some cases the Internet of Things is being used, I want to get an idea from those on the webinar today, what kind of applications you've seen on projects and see what the most common integrations between lighting and power is between other systems. And once again, if you want to jump on and scan the QR code, we'll jump to the next slide here and see the results of what applications people have seen most often. So it was interesting, similar to what we were looking at this morning. Mechanical systems, definitely a common integration between lighting. As I mentioned earlier, many codes now are requiring mechanical to tie in, utilize occupancy sensors for setbacks. Security is definitely another one that we're seeing more and more integration and more smarts into additional systems. One of the examples discussed briefly this morning as well was going through utilizing security to control window shades as part of lockdown systems or other security events inside K through 12 schools, higher ed schools, and seeing automated shades closing when going into a security event to help ensure that windows are not open and people can't see inside of classroom spaces. So definitely a common one that we're starting to see more and more often. So we'll jump on to the next slide here. We've talked a lot about what kind of applications can take place, what kind of systems we're seeing tied together. But ultimately, the question for this group of architects, engineers, building owners are really, what are the steps to implement? And one of the first ones really starts early in design, starts with developing out specifications and utilizing a section or a division that's not used as frequently, but is something that's starting to be used more and more on projects. And that's the Division 25 Integrated Automation section. This section really focuses entirely on tying in all these different control systems. Whereas you might have Division 23 focus on the HVAC control, and 26 focus on the lighting control, and all of these standalone contractors, standalone sets of drawings, focusing on individual system controls. The integrated automation system is focused on tying these all together into one centralized smart building brain, if you want to call it that. The goal of this section is to go through and identify those goals, identify the hardware, the software, the different communication protocols required, so that all of these different systems, whether they be HVAC, window shades, energy meters, that they all are able to share their data seamlessly and all able to interact and automate between all of these different systems. So the intent of this section is really, as I said, to go into the parts and smarts of how we are going to compile all this data from all these different sources, and then also how we're going to keep it safe. And that's the next slide that we've got here, is really focusing on one item that's becoming more and more prevalent overall, and it's the cybersecurity component of it. Now, as Kristina mentioned earlier, as great as it is that we're able to tie all these systems together and utilize a common network to be able to have all of our systems communicate, that also opens up a vulnerability if that system is open to the outside world, and if that system is open to corporate networks or anything like that within a building. So one of the big concerns and big items to make sure gets addressed in that Division 25 specification section and any integrated automation design is ensuring that network devices are only accessible to those who it should be, ensuring that there's a plan and protocols in place for ensuring that systems remain patched and updated, ensuring that intrusions or anything that inside the network is monitored, and ensuring that there is an air gap between the building systems and then the corporate networks, where there's a lot of going to be very important information and a lot of intellectual property associated with that network. So ensuring that from the very beginning of the design, those firewalls are in place, those protocols are identified, is one of the largest hurdles between being able to fully automate and fully make our buildings intelligent versus weighing off on those cybersecurity concerns. So we'll do one last poll here for anyone and really just get a feel for those on the line. On the projects that you've worked on, who has seen a Division 25 specification before, and how often are people seeing these used on their projects? That was a very even split. All right, looks like we're getting a little bit more on the nose than yeses. But yeah, it's definitely something that we are seeing utilized more and more often, but it's still, I would say, not applicable or not used on a typical project. Definitely ones that are more on the cutting edge, more on the forefront of going forward with especially energy efficiency and sustainability side of things. So moving along, after we've gone through the design component of it, after we've broken out really what those requirements are, one of the roles that we see on projects that are really pushing for this fully integrated smart building is the role of a master system integrator. It goes beyond just the individual controls contractors that we would see on typical buildings, where we have an HVAC controls guy and we have a lighting controls contractor, and then we have all of these separate systems that maybe don't all communicate together. And if the project's intent is for all of these different individuals to be able to coordinate and integrate their systems seamlessly, the need for this master system integrator becomes bigger and bigger. The goal of this role is to ensure that instead of all these systems operating in silos, where they say that their scope has been complete, even though maybe they haven't fully integrated into another competing vendor's platform, or is actually getting all the data that they're supposed to get from another system, the master system integrator's role is to ensure that this all gets completed, to ensure that data flows seamlessly between these different systems, between these different sets connected smart devices, and ensuring that every step along the way, the cybersecurity component is addressed so that there aren't any vulnerabilities within the network. Now, this role can be completed by different multiple entities, but the more the team works as a team and the more that they all fall under the same umbrella, to be able to understand all these different systems will allow for a much more seamless process, which allows for the gathering of all that data, which we can then use in our next slide here in our next step of the process, which is ensuring that after the end of the project that we do put together a good monitoring-based commissioning plan and a good program within the buildings. Now, what this does then is takes all of that data, all of those integrations, all of those protocols that were put together during the design, during the construction of a project, and then ensuring that all that data gets put to good use. And going through this process, the team is able to apply analytics and diagnostics to be able to not just say that the building is operating as it was when it was completed, but also to create a feedback loop that the building can learn where there are vulnerabilities, where there are optimizations, and really be able to learn how to improve the performance. So instead of just looking at what was designed and what was assumed during design, actually seeing how it operates and learning from what the actual loads on the building are, how people actually use the building, and then being able to optimize the systems from there. This also can be used for facilities teams to be able to identify and be reactive towards their maintenance instead of being proactive. All right, I got that backwards, sorry. Go to proactive instead of reactive so that they can actually get ahead of when repairs are needed and get to the fixes that are of the highest benefits, as opposed to just jumping from fire to fire and putting out the things that are of most importance at the time. So that's the full big picture then of now saying that we have taken all of these individual systems, we've combined them into the Internet of Things to be able to utilize sensors across systems and really fully integrate the building. And then once we have it all fully integrated, be able to use that data and learn how we can make improvements and how we can optimize our systems as time goes on. On that note, I'll open it up to anybody. I'll thank everyone for taking the time, taking their lunchtime to sit with us today, and open up to questions for anybody.
Thanks, Mike. Yeah, please enter your questions in the box.
Well, it doesn't look like there's any questions. You did a great job, Michael and Kristina. I think everybody must have everything answered. If there are some questions later, feel free to reach out to Michael or Kristina. They'll be happy to answer anything. And thank you for participating in today's webinar. We hope it was informative. If you have comments or suggestions for improvements, please send us a note. We welcome any feedback, and keep a lookout for our next Interface Educational webinar. Thank you so much, and enjoy the rest of your day.
Thank you.
Thanks, Bill.